Here's what this means for you before we go any further. Every advanced weapon system the United States military operates runs on chips. The JDAM guidance kit that turns a dumb bomb into a precision munition. Chips. The Link 16 data network that allows F-35s to share targeting data in real time. Chips. The Aegis combat system on every American destroyer in the Pacific. Chips. The AI systems currently being integrated into drone swarms, electronic warfare suites, and battlefield intelligence platforms. Chips. Every single one of these systems depends on a supply of advanced semiconductors that, as of today, flows predominantly from one island, Taiwan. South Korea just made the most consequential bet in the history of semiconductor manufacturing to change that reality, and the strategic implications of that bet run directly through the question of whether Taiwan remains worth defending and whether Beijing has noticed. This channel runs on no corporate funding, no government backing, and no advertising pressure telling us what to leave out. If this kind of analysis, the kind that connects semiconductor investment announcements to Pacific military deterrence, matters to you, hit subscribe and turn on notifications. This is the analysis that mainstream coverage stops well short of completing. Let me show you exactly what South Korea announced because the numbers are extraordinary. In May 2024, the South Korean government unveiled what it officially calls the semiconductor megacluster. The plan targets a 21-kilometer industrial corridor stretching from Yongin to Pyeongtaek, located roughly 40 kilometers south of Seoul. The South Korean government committed to facilitating $470 billion in private sector investment over the next 2 decades, primarily through Samsung Electronics and SK Hynix. The megacluster is designed to house 16 new semiconductor fabrication plants, or fabs, by 2047, alongside hundreds of supporting supplier facilities, research centers, and testing operations. Samsung alone committed $228 billion to advanced chip production as part of this initiative. SK Hynix, the world's second-largest memory chip manufacturer, pledged an additional $75 billion to expand its production facilities in Incheon and Cheongju. The Korean government will support the build-out with regulatory streamlining, infrastructure investment, and targeted tax incentives that analysts estimate are worth tens of billions of dollars in additional effective subsidy. The official framing from Seoul has been straightforward. This is about economic competitiveness, national industrial strength, and supply chain security. South Korea wants to protect and expand the chip industry that already accounts for roughly 20% of its total export revenue. The argument is sensible on its face, but here's what the official statement leaves out, and what it leaves out changes the entire picture. To understand why Taiwan is watching this with deep unease, you need to understand what the silicon shield actually is and how it works. Taiwan's semiconductor industry was not built by accident. It was built deliberately, over 37 years, with the implicit strategic understanding that making Taiwan indispensable to the global economy was one of the most powerful forms of deterrence available to a small island that cannot match China's military might through conventional means. TSMC, the Taiwan Semiconductor Manufacturing Company, founded in 1987, is the engine of that strategy. Today, TSMC produces approximately 92% of the world's semiconductors at 5 nanometers and below. To put that in concrete terms, a 5-nanometer chip contains roughly 170 million transistors in a space the size of your fingernail. These are not commodity chips. These are the chips that power the most advanced AI processors, the most sophisticated military guidance systems, and the next generation of communications infrastructure being deployed across every major economy on Earth. No other company, not Samsung, not Intel, not any Chinese manufacturer, can currently produce these chips at scale with competitive yields. That irreplaceability is not an accident. It is Taiwan's most important strategic asset. The logic of the silicon shield is simple. Any military action against Taiwan that disrupts chip production triggers an immediate global economic catastrophe. Supply chains freeze. Technology companies lose their most critical inputs. Defense contractors face component shortfalls. Every government on Earth, including China's, has an overwhelming economic incentive to prevent that disruption. Taiwan's chips are the tripwire. Military action pulls the tripwire. And so, in theory, military action is deterred. That is the silicon shield, and South Korea's $470 billion bet is very slowly, beginning to thin it. Here's what they're not telling you about what South Korea's expansion actually does to this calculus. The silicon shield does not work as an all-or-nothing mechanism. It works as a function of irreplaceability. The more replaceable Taiwan's chips become, even partially, the weaker the deterrent effect. You do not need to eliminate Taiwan's role entirely to change the strategic calculation in Beijing. You only need to reduce it enough that a Chinese leadership team looking at an invasion scenario can say, yes, the disruption would be painful, but survivable. That threshold, painful but survivable, is a very different calculation than catastrophic and unacceptable. South Korea's mega-cluster does not threaten to reach that threshold tomorrow. The build-out runs through 2047. Samsung's foundry yields at the most advanced nodes still lag TSMC's measurably. The engineering talent, the equipment supply chains, the institutional knowledge embedded in TSMC's operations over nearly 4 decades, none of that transfers overnight, but the direction of travel is clear. By 2030, Samsung projects it will achieve competitive yields with TSMC at the 2-nanometer node. By 2035, South Korea's combined semiconductor output across Samsung, SK Hynix, and the mega-cluster's full ecosystem is projected to approach parity with Taiwan's total output across all chip categories, not at the most advanced leading edge specifically, across all categories. Here's what that shift means. Today, 92% of the world's most advanced chips come from Taiwan. The evidence indicates that by 2035, that figure could be closer to 55% to 60% when South Korean capacity, TSMC's overseas fabs in Arizona and Japan, and even incremental gains by Intel are factored together. 55% is still a dominant position, but it is not irreplaceable. And not irreplaceable is a fundamentally different deterrent than, without this island, the global economy collapses. The distinction seems technical. In Beijing's strategic planning rooms, it is the difference between action and restraint. Now let me show you the math directly, because the numbers make this concrete in ways that are hard to dismiss. TSMC's revenue in 2023 was approximately $69 billion. Its advanced nodes, 5 nanometers and below, generated roughly 53% of that figure, or about $36 billion. That $36 billion represents chips that no other company on Earth can replicate at competitive scale. It is the economic core of the silicon shield, measured in dollars. Samsung's foundry division, the business unit that manufactures chips for external customers the way TSMC does, generated approximately $15 billion in revenue in the same period. Its market share in advanced logic foundry work sits at roughly 12%, compared to TSMC's approximately 60%. The gap is real, it is large, and it is closing. SK Hynix presents a different dimension of the same story. SK Hynix already dominates the market for high-bandwidth memory, the specific chip architecture that NVIDIA's H100 and H200 AI accelerators depend on to function. Every AI data center running large language model training, every military intelligence platform using machine learning to process satellite imagery and signals intelligence runs on HBM chips. SK Hynix currently produces the majority of the world's most advanced HBM versions. That is not a peripheral market. That is the infrastructure of the AI arms race. The combined picture: South Korea already owns the critical memory component of the AI chip stack. It is now making a $470 billion bet to close the gap on advanced logic. If both succeed, and the investment levels suggest serious commitment, the argument for Taiwan's unique irreplaceability weakens materially by the early 2030s, not collapses, weakens. In deterrence architecture, weakening the tripwire is serious business, even if the wire remains in place. While the official statements from Washington have celebrated allied semiconductor diversification, something more important is happening in Beijing. China's leadership made a decisive strategic calculation in 2019 when the Trump administration imposed export controls on Huawei's chip supply. The restrictions worked. They significantly damaged Huawei's competitive position in 5G infrastructure globally, but they also delivered a lesson that Beijing has spent 6 years acting on. The chip is the weapon. Whoever controls semiconductor supply controls the strategic leverage. China's response has been to spend more than $150 billion on domestic semiconductor development between 2019 and 2024. SMIC, China's leading chip manufacturer, has achieved production at the 7-nanometer node using equipment that American export controls were specifically designed to prevent it from accessing. The methods by which SMIC accomplished this are still being studied by American intelligence analysts. What is not in dispute is the outcome. China demonstrated that determined state-directed investment can partially circumvent technology restrictions that were assumed to be more durable. China currently consumes roughly 35% of global semiconductor output annually. It produces domestically, at competitive quality levels, perhaps 15% of what it consumes. That gap is the remaining leverage point. That gap is what American export controls and allied diversification programs are trying to preserve. And that gap is narrowing, on both ends simultaneously. Chinese domestic production is climbing, and the global supply of chips is diversifying away from Taiwan, reducing the catastrophic consequences of any single supply disruption. Beijing's strategic planners are not watching South Korea's mega-cluster announcement as a business story. They are watching it as a data point in a multi-decade deterrence calculation. Every new fab outside Taiwan makes the silicon shield slightly less absolute. Every $10 billion invested in South Korean or American chip production is a reduction in the cost Beijing would face in a conflict scenario. The math is not comfortable. Russia's role in this picture is quieter, but worth understanding. Moscow is not a semiconductor power. Sanctions and export controls following 2022 have effectively collapsed Russia's access to advanced chips, and its domestic industry has not recovered. But Russia's experience in Ukraine has provided Beijing with a crucial strategic data point. Economic sanctions, even comprehensive ones, do not stop a determined adversary from acting militarily if the leadership has decided the objective is worth the cost. Russia absorbed the most extensive, coordinated economic sanctions in modern history and has continued its military campaign for more than 3 years. Beijing is drawing explicit conclusions from this. The lesson is not that economic interdependence is irrelevant. The lesson is that economic pain has a threshold below which it becomes tolerable if the strategic objective is important enough. The question for Taiwan's deterrence posture is whether semiconductor supply disruption would generate economic pain above that threshold, or whether a combination of Chinese domestic production, South Korean capacity, and American reshoring reduces the disruption enough to make the pain tolerable. That question does not yet have a definitive answer, but the trajectory of the answer is moving in a direction that Taiwan's strategic planners are acutely aware of, and it is moving faster than American public discourse has acknowledged. Here's the dimension almost nobody in Western media is discussing openly. Taiwan is not sitting still. TSMC's accelerated overseas investment, the Arizona fabs, the Japan facilities, the discussions about a European facility in Germany, is not primarily driven by enthusiasm for geographic diversification. It is driven by external pressure from the United States government, from customers who want supply chain resilience, and from a strategic assessment within TSMC's leadership that being seen to cooperate with allied diversification efforts is essential to maintaining the political support Taiwan needs. But the economics of overseas expansion are brutal. TSMC, Arizona, the first American fab, now producing 4-nanometer chips, costs approximately 50% more per chip to operate than equivalent Taiwan facilities. That cost differential is covered by American government subsidies, roughly $6.6 billion in direct grants allocated under the CHIPS and Science Act. Without that subsidy, the Arizona fab would not be economically viable at anything approaching competitive pricing. TSMC Chairman Mark Liu has stated publicly and directly that overseas fab economics are significantly more challenging than Taiwan operations. He has also stated that TSMC has no intention of moving its most advanced production, its leading-edge research, and the fabs that push the technology frontier outside Taiwan. The overseas facilities produce technology that is 1 or 2 generations behind what TSMC is developing domestically. The most advanced chip, Namstarter Taber Nestor Starter Bestelkerter Matterter Chetter Chetter Trucker Chucker Stopker Stun Matter Stuffer Ducker Stalker Stopper Melter military applications and AI systems are still made in Taiwan. and TSMC intends to keep it that way. That decision preserves Taiwan's leading-edge advantage. It also means that the silicon shield's deterrent effect, at the very highest technology levels, remains anchored in Taiwan for the foreseeable future. But it does not stop South Korea's megacluster from building a credible alternative at the tier just below the absolute frontier, which is the tier that the vast majority of military and commercial applications actually require. 3 predictions with timeframes attached. By 2027, the talent competition between South Korea's megacluster and Taiwan's existing semiconductor ecosystem will produce the first significant public friction between Seoul and Taipei. South Korea needs approximately 30,000 additional trained semiconductor engineers to staff the megacluster at full capacity. Taiwan's engineering universities and TSMC's own training programs produce a portion of the global supply of engineers with directly applicable skills. Active recruitment by Samsung and SK Hynix targeting Taiwan-trained engineers is already occurring. When that recruitment reaches a scale that Taipei considers destabilizing to its own workforce, expect a diplomatic response that neither government currently wants to discuss publicly. By 2028, China will deploy South Korea's semiconductor expansion as a specific diplomatic argument in its engagement with Southeast Asian nations, particularly Vietnam, Indonesia, and Malaysia. The argument will be straightforward. The silicon shield has always been overstated. Alternative supply is being built, and Beijing's long-term semiconductor relationships are more reliable than dependence on a geography that American policy is actively trying to make less critical. Watch for Chinese semiconductor investment proposals to these 3 countries in the 2026 to 2028 window as the opening move of that argument. By 2030, the United States will face a policy contradiction it cannot cleanly resolve. American industrial policy, through the CHIPS Act, through coordination with South Korea and Japan, will have made meaningful progress toward reducing dangerous chip concentration in Taiwan. And American security policy will simultaneously discover that Taiwan's deterrence posture requires additional military reinforcement precisely because the economic argument for defending the island has become less singular. The same policy framework that celebrates supply chain resilience will need to explain why the Pacific defense budget requires a significant increase at the same moment the economic rationale for Taiwan's protection has diversified. That conversation has not started publicly. It needs to. Here is what is actually happening, stated plainly. Taiwan built the most powerful non-military deterrent in modern geopolitical history. It did so through extraordinary industrial execution over 4 decades. That deterrent is not collapsing. It is not being abandoned. TSMC remains the most sophisticated semiconductor manufacturer on Earth, and that will remain true well into the 2030s. But the deterrent is beginning a slow erosion, driven by legitimate, necessary, strategically sound decisions by the United States and its allies to diversify supply chains that were dangerously concentrated. The same policy decisions that protect the American economy from a Taiwan contingency also, at the margin, reduce Beijing's economic incentive to avoid that contingency. There is no clean solution to that contradiction. There is only the question of whether American and allied military deterrence is being built fast enough to fill the gap as the economic deterrent thins. The shipbuilding rates, the munitions stockpiles, the Pacific basing posture, the integrated deterrence architecture with Japan, South Korea, and Australia, these are the variables that matter now, and whether they are moving fast enough, that is the question this channel will return to. Drop your prediction in the comments. Which comes first? The Seoul-Taipei talent friction breaking into the open, China deploying the chip diversification argument against Taiwan and Southeast Asia, or the American policy contradiction becoming publicly undeniable? I read every single comment. Tell me what you think. If this gave you a framework for understanding what the South Korea chip announcement actually means for American security, a framework the business coverage definitely did not provide. Share it with one person who needs to understand what's at stake. Not for clicks, because this story is not getting the attention it deserves. The next video goes somewhere even this one didn't reach. The specific classified assessments of what happens to American warfighting capability in the 72 hours after a Taiwan contingency begins, and which chip dependencies create the most dangerous single points of failure. Subscribe so you're there when it lands.